Hi students, welcome to the part 2 PYQ discussions of the chapter vectors. Okay, so in this video we will be discussing questions from 2024 as well as from 2025. So many questions will be discussed, and along with that we will be discussing the concepts and the shortcuts of that questions. Okay, so stay tuned until the last question. Okay, and let's start. Our very first question, two vectors are given, vector A and vector B. Vector A is equal to 2i minus j plus 3k, and vector B is equal to 3i minus 5j plus k. And another vector, vector C, is given such that vector A cross vector C is equal to vector C cross vector B. And vector A plus vector C dot vector B plus vector C is equal to 168. Then you need to find the maximum value of magnitude of C square. Okay. So let's start from here. Okay, that is vector A cross vector C is equal to vector C cross vector B. Okay, I think we have discussed a question like this in the last session. Okay, that is part 1. So if a vector is represented like this in terms of an equation, and in the LHS and RHS there is a cross product like this, we need to align the vectors at first. That is, here vector C is the second vector, here vector C is the first vector. Vector C is common in LHS as well as in RHS. Therefore, we should assign the position of vector C. That means vector C should be either vector C should be the second vector or vector C should be the first vector. Okay, okay, like that. Therefore, I am transforming this vector C as the second vector using properties of cross product. Therefore, it will be vector A cross vector C is equal to minus vector B cross vector C. Okay. Therefore, after transforming this to the right hand side, it will be vector A cross vector C plus vector B cross vector C is equal to 0. That is, vector A plus vector B cross vector C is equal to 0. Okay, you should know the result if the cross product is like this. That is, if vector A cross vector B is equal to 0 vector, then one vector can be represented as the scalar multiple of other vector. That is, either vector A can be represented as a scalar multiple of vector B, or vector B can be represented as a scalar multiple of vector A. Okay. So, which one is represented as a scalar multiple of other, that can be conveniently taken according to the situation. Okay. Therefore, here I am representing like vector C. Okay, vector C is equal to lambda into vector A plus vector B. Okay, vector C is equal to lambda into vector A plus vector B. Okay, then I think this is done. Okay, the information from this is extracted, and from the next relation, that is vector A plus vector C dot vector B plus vector C is equal to 168. Just open the bracket, you will get vector A dot vector C plus vector A dot vector B plus vector A dot vector C, vector A dot vector B, plus vector C dot vector B plus magnitude of C square is equal to 168. Okay, so vector A dot vector C and vector C dot vector B, I think vector C is common. This is a dot product. Therefore, applying distributive property of dot product over vector addition, you will get vector A plus vector B dot vector C, and this magnitude of C square we can write it here, plus vector A dot vector B, that we can formulate from here, that is 2 minus 1 3, 3 minus 5 1, that is 6, 5 that is 11, and 14, that is plus 14 minus 168 is equal to 0. Okay, and what is vector C? Lambda into vector A plus vector B. Okay, so be careful, I am skipping a step here. That is, vector C is equal to lambda into vector A plus vector B. Okay, so for this becomes lambda into vector A plus vector B, magnitude of vector A plus vector B the whole square, and this becomes lambda square into magnitude of vector A plus vector B the whole square. Therefore, this is lambda square into magnitude of vector A plus vector B the whole square plus lambda into again magnitude of vector A plus vector B the whole square minus 154 is equal to 0. Okay, so what is vector A plus vector B? Vector A plus vector B, if you add it, you will get 2 plus 3, that is 5i. Okay, and minus j, that is minus 6j, and 3k plus k, that is what? 4k. That is 5i minus 6j plus 4k, and the magnitude of squares will be 5 square plus minus 6 square plus 4 square. That is 25 plus 36, that is 61. 61 plus 16, that is 77. That is magnitude of vector A plus vector B whole square is 77. That is 77 lambda square plus 77 lambda minus 154 is equal to 0. A quadratic equation in terms of lambda, now we can cancel, right? Therefore 77, 77 and 154 got cancelled and becomes minus 2. Okay, therefore lambda square plus lambda minus 2 is equal to 0. That is a quadratic equation lambda. There will be two values of lambda. The first value will be 1 and second value will be minus 2. Okay, 1 and minus 2 are the values. Okay, you will easily get up to by method of solving quadratic equations, either factorization method or by direct inspection method or using the formula of quadratic equation. Okay, that is two values you will get 1 and minus 2. But here we need to find the maximum value of magnitude of c square, right? Okay, to the next slide. Magnitude of c square is like, okay, magnitude of c square is equal to lambda square into magnitude of vector A plus vector B whole square, that is 77. Okay, lambda has two values, 1 and what? Minus 2. But you are squaring lambda, right? That is lambda square is equal to 1 or lambda square is equal to what? 4. Okay, assigning 4 here only you will get the maximum value. That is the maximum value of magnitude of c square is 4 into 77. That is 308. Okay, that is 308 is the maximum value of magnitude of c square. Okay, that's done and understood. Question number 1. And question number 2. The option is, I think, 3. Option number 3. Okay, next one. Yeah, very easy question. If the components of vector A, it is given as alpha A plus beta J plus gamma K, along and perpendicular to vector B is equal to 3i plus j minus k, respectively are 16 by 11 into 3i plus j minus k and 1 by 11 into minus 4i minus 5j minus 17k. Okay, then you need to find alpha square plus beta square plus gamma square. That is, you need to formulate the value of A and find its square of its magnitude. Okay, that's all. So, yeah, let's formulate it. Let's take this as vector A. Okay, and it's along and perpendicular to vector B. Okay, it will be like this. This I am taking it as vector P, this I am taking it as vector Q. Though this is vector A and this is vector P and this is vector Q. Okay. So that's all. I just add using triangular law of vector addition, you will get the answer. If the components of vector A along and perpendicular to vector B, so vector B are 16 by 11 into 3i plus j minus k. Okay, that's just add it. Okay, that is vector A is equal to vector P plus vector Q. Okay, therefore 16 by 11 is common. Okay, we don't have to consider the denominator for now. That is, it is 11. Okay. That is 16 into 3 is 48. 48 minus 4 is 44i. And 16 minus 5, that is plus 11j. And minus 16 minus 17, that is minus 33k. Okay, divisible by 11. Therefore, it will be 4i plus j minus 3k. Okay. Therefore, you need to find the magnitude of this square of this one. Right? It is 4 square plus minus 1 square plus 3 square, that is 26 is the final cut answer for this one. Okay, and that's about the second question. Okay, then the third one. Yeah, a very lengthy question. Let the position vectors of the vertices ABC of a tetrahedron ABCD be I plus 2j plus k, I plus 3j minus 2k, 2i plus j minus k respectively. The altitude from the vertex D to the opposite face ABC meets the median line segment through A of the triangle ABC. Okay. At the point D. Okay. A length of AD is given like root 110 by 3 and the volume of the TT is also given, that is root 805 by 6 root 2. And you need to find the position vector of E. Okay. A question which is based on algebra and area of figures, area and volume of figures. Okay. Let's sort it out to the next slide. Okay, we cannot complete this in this slide. Okay, we need to draw the diagram first. Okay, like let's start with the diagram. Okay, let's start from here. Okay, that is A, B, C. Okay, like this. Tetrahedron means a triangular pyramid. Okay. Okay. From here, a perpendicular is drawn, and this cuts the perpendicular. Okay, at the point E. Okay. This is the median, right? Therefore, we can take it as this is C, and we can take it as F. This is D, and this is given, right? I think AD is given. AD is root 110 by 3. Okay. Root 110 by 3, and volume is given. Volume is okay. Let's mark the position vectors first. A is I plus 2j plus k. That is I plus 2j plus k. Okay, A is I plus 2j plus k. I plus 3j minus 2k. That is I plus 3j minus 2k. And what about C? I plus 3j minus 2k. 2, 1 minus 1. That is 2i plus j minus k. Okay, 2i plus j minus k. Okay, and the volume is root 805 by 6 root 2. And the volume is root 805 by 6 root 2. You need to find the position vector of E, that is vector OE is which you need to find here. Okay, so how are you going to do this one? Let's solve it. See, how are you going to find the position vector of E? What is your objective before starting this question? See, your objective is to see this ADE. It is a right angle triangle, right? Therefore, what you need to do is you need to identify the height of this tetrahedron, that is this triangular pyramid, that is with D. Okay, and if you know D, you can find AE. Okay, and since F is the midpoint, we can formulate the position vector of F using section formula. Okay, now you will get vector AF. You will get vector AF and magnitude of vector A. Okay. Once you got vector AF, you need to identify the unit vector in the direction of vector AF. That is, vector AF is equal to vector AF cap is equal to vector AF divided by magnitude of vector AF. Okay. Now you got a unit vector in the direction of vector AF. Then you can easily formulate that is itself a unit vector in the direction of vector A. Okay. If you got a unit vector in the direction of vector A, you can formulate vector E, and from that vector A, you can formulate a position vector of E. Okay. So let's start. Our objective is to find the height of this triangular pyramid first. Let's use the volume here. Okay, that is volume of a tetrahedron is equal to 1 by 3 into base area into height. That is equal to that is equal to root 805 divided by 6 root 2. We might need to use another slide also. Just be patient until we solve this question. Okay. So base area is area of this triangle, that is 1 by 3 into 1 by 2 into vector AB cross vector AC, the magnitude into height. Height is D. I think from here you will get D is equal to root 805 divided by 6 root 2. This 6 and this 6 got cancelled. We need to find the vector AB cross vector AC, that we can formulate from here. That is IJK. Okay, and what is vector AB? That is 0. Okay, let's I plus 2j plus k and I plus, okay, that is 0, that is j1, that is 3 minus 2 is 1, and minus 2 minus k is minus 3, and from here it will be 1 and minus 1 and minus 2. So it will be like this. So this will be 1 into minus 2 is minus 2, minus 2 minus 3 is minus 5i, that is minus 5i magnitude of minus j into plus 3, that is minus 3j and minus k. Okay, into d is equal to root 805 divided by root 2. Therefore, this is magnitude of this is 25 plus 26 plus 9, that is 35, root 35. That is DE is equal to root 805 divided by 2 into 35. This is root 35. If it goes there, it becomes root 2 into root 35. Okay. I think it can be divisible. It will be divisible by 35. 35 times 20 is 700. That is 23, right? Yeah, 23. 23. That is D is equal to what? root of 23 by 2. Okay, we got a D. Okay, and we need to formulate A. Okay, since this is a right angle triangle, we can apply Pythagoras theorem to get the value of A. That is AD square, that is 110 by 9. Okay, is equal to AE square plus, and this is 23 by 2. 23 by 2, that is 110 by 9 minus 23 by 2 is equal to AE square. That is AE square is equal to 110 into 2 is 220, and 23 into 9 is 207, right? That is 220 minus 207, that is 13. That is 13 by 18. That is AE is equal to square root of 13 divided by, this is 3 root 2. Okay, now you got A. Okay, I think halfway there you got the value of A. Okay. Next one. See, this A can also be represented like this. AE is equal to magnitude of vector A. Okay, that both of them are same. Okay. Then we need to formulate the position vector of F. It will be like vector OF is equal to I plus 2i, that is 3i by 2 plus 3, that is 2j, and minus 2k, that is minus 3k by 2. That is 3i by 2 plus 2j minus 3k by 2. That will be vector AF. Okay, OF. And you need to find vector AF. And vector AF will be like 3 by 2i plus 2j minus 3 by 2k minus, okay, what is vector A? I plus 2j plus k. I plus 2j plus k. Okay, that is next slide. That is vector AF is equal to, vector AF is equal to I by 2. Okay, I by 2, this got cancelled, and this is minus 5 by 2, right? Yeah, minus 5 by 2. That is minus 5 by 2j. This is what vector AF is. Now we need to formulate a unit vector in the direction of vector AF like AF cap is equal to I by 2 minus 5 by 2j. Okay, k. Okay, I by 2 minus 5 by 2k is there. Okay, by mistake I got it as k. K divided by magnitude of 1 by 4 plus, this is 25 by 4. That is AF cap is equal to I by 2 minus 5 by 2k divided by, this is root 26 by 2. This 2 got cancelled. That is AF cap is equal to I minus 5k divided by root 26. This is a unit vector in the direction of vector AF. At the same time, a unit vector in the direction of vector AE. Okay. And next one. Therefore, vector AE is equal to a unit vector in the direction of vector AE, that is AF cap into magnitude of vector AE. I think you already know the magnitude of vector AE. What is magnitude of vector AE? That is root 13 by 2 root 2. Root of 13 by 3 root 2 into what is AF? I minus 5k divided by root 26. See, 13 by 2 into root 26, that is root 2 into root 26 is 52. 13 by root 52 is 1 by 4. Root of 1 by 4 is 1 by 2. 1 by 2 into 3 is 6. That is I minus 5k by 6. This is what vector A is. Okay, we are not done yet. We need to find the position vector of A. Okay, so from this we can formulate it like this. Vector OE minus position vector of A is equal to I minus 5k divided by 6. That is vector OA is equal to I minus 5k by 6 plus vector OA. That is vector OE is equal to I minus 5k by 6 plus vector OA. Vector OA is I plus 2j plus k. That is plus I plus 2j plus k. Okay, therefore it will be 6i, that is 7i, 12i, okay, 12i plus 12j and 6k. Plus minus 5k is k divided by what? 6. Okay, that is the final cut result is 7i plus 12j plus k divided by 6. I think option, okay, option 4. That is the final cut answer. Okay, a slightly lengthy question but purely based on the NCERT. Okay, the tetrahedron, apart from tetrahedron, purely based on NCERT. Okay, so next one. Okay, an easy one. Let the arc AC of a circle subtend a right angle at the center O. Okay, if the point B on the arc AC divides the arc AC such that length of arc AB divided by length of arc BC is equal to 1 by 5. It's a 2025 question. Okay, I forgot to add the year there. And vector OC is equal to alpha vector OA. A linear combination is given plus beta into vector OB. So you need to find alpha plus root 2 into root 3 minus 1 into beta, the value of that. Okay, so how are you going to find the value of that? Let's use a concept from trigonometry. Okay, let's draw the arc first. The arc will be like this. OAC. Okay, length of arc AB divided by length of arc BC is equal to 1 by 5. This we can take it as AB. Okay, so if this is theta, okay, subtended right angle means this will be 90 minus theta. Okay, so you know the relation between for sectors like, see, consider a sector of a circle like this having arc length L, radii R, and let theta be the angle subtended by the arc length towards the center of the circle. Okay, then what is the relation between arc length, radius and theta? L is equal to R theta. That theta should be in radians. Okay, L is equal to R theta. Okay, so in this case, radii will be same. Okay, that is, these are part of a same circle. The arcs are part of a same circle. Okay, so I am applying the relation directly over here. Okay, so what is length of arc AB? Length of arc AB is this one. Okay, that is length of arc AB is equal to radius of the circle into angle subtended by the arc length towards the center. That is R theta. That is R theta divided by what is length of arc BC? That is R into the angle subtended by the arc length towards the center of the circle. That will be equal to 90 minus theta. That is into 90 minus theta, which is equal to 1 by 5. This and this got cancelled. After cross multiplication, you will get 5 theta is equal to 90 minus theta. That is 6 theta is equal to 90. Therefore, the value of theta will be like 15. Okay, what is the value of theta? 15. Therefore, here we can write it as 15 and this will be what? 75. Okay, now we got the angle. Now we can formulate alpha and beta from here itself. Okay, I think it will be better if you do it in the next slide. That is vector OC is equal to alpha into vector OA plus beta into vector OB. That is plus beta into vector OB. Sorry, beta into vector OB. Okay, let's draw the figure here also. That is OABC. That is OA, B and C. This angle is 15 degree and this angle is 75 degree. Okay, let's formulate alpha and beta here. My question is how are you going to formulate alpha and beta from here? There is a method actually. See, we can use vector dot product for that. Okay, see, vector OC is here in the left hand side. Okay, so let's dot with OC on both sides. Okay, apply dot product of vectors on LHS and RHS with vector OC. That is vector OC dot vector OC is equal to alpha into, I am opening the bracket also, plus beta into vector OB dot vector OC. See, vector OC dot vector OC is what? Magnitude of vector OC square. That is nothing but the square of radius of the circle. Vector OA dot vector OC. What is the value of vector OA dot vector OC? That's 0 because vector OA and vector OC are perpendicular vectors. Therefore, the dot product will be 0. This got cancelled. And beta into magnitude of vector OB into magnitude of vector OC into angle between OB and OC. That is cos 75. Okay. See, vector OB, we know that vector magnitude of vector OB is equal to magnitude of vector OC is equal to magnitude of vector OA. Okay, so this becomes magnitude of vector OC. Therefore, magnitude of vector OC into magnitude of vector OC is magnitude of OC square. Got cancelled. This also got cancelled. Therefore, beta becomes what? 1 by cos 75. Okay, the value of beta is nothing but 1 by cos 75. Okay, like that, if you apply another dot product, we will get the value of alpha also. I think we can apply dot product on both sides with vector OA. This will be 0 then. Okay, that is vector OC dot vector OA is equal to alpha into magnitude of OA square plus beta into vector OB dot vector OA. That will be beta into magnitude of vector OB into magnitude of vector OA into cos 15. Okay, cos 15. This got cancelled. Okay, and this can be written as, I am taking the alpha to the left hand side, minus magnitude of OA square into alpha is equal to this vector OB can be written as magnitude of vector OA. Magnitude of vector OB can be written as magnitude of vector OA. That is magnitude of vector OA into magnitude of vector OA is, that is magnitude of vector OA the whole square into beta into cos 15. Okay, got cancelled. Therefore, alpha is equal to what? Minus beta into cos 15. That is minus 1 by cos 75 into cos 15. That is what alpha is. Okay, so how are you going to transform alpha? Easy. This cos 15 can be transformed as sin 75, right? That is alpha is equal to minus sin 75 by cos 75. That is minus tan 75. Okay, that's done and dusted. Almost done. Then we can apply to the final final expression. That is alpha plus root 2 into root 3 minus 1 beta, right? Alpha plus root 2 into root 3 minus 1 into beta. What is the value of alpha? Minus tan 75. That is equal to minus of 2 plus root 3. Okay, that is minus of 2 plus root 3 plus root 2 into root 3 minus 1 into, what is the value of beta? 1 by cos 75. That can be written as 1 by root 3 minus 1 divided by 2 root 2. This 2 root 2 will come here. It becomes 2 root 2 by root 3 minus 1. Okay, got cancelled. And 2 root 2 into root 2 becomes 4. And this will be minus 2 minus root 3. So the net answer will be 2 minus root 3. Okay, that's all. Okay. 2 minus root 3 the final cut answer. A very beautiful problem. We are using the concept of trigonometry also. We can easily do this. Okay. Hopefully you got the idea here. Okay, let's move to the next question. Before that, the option is 1. First option. Okay, let's move to the next one. Okay, the position vectors of 3 vertices of a triangle are given like 4 vector p plus vector q minus 3 vector r, minus 5 vector p plus vector q plus 2 vector r, and 2 vector p minus vector q plus 2 vector r. Okay, I am marking the vertices here like a, b and what? C. Okay, if the position vectors of orthocenter and circumcenter of a triangle are vector p plus vector q plus vector r, and alpha vector p plus beta vector q plus gamma vector r, then you need to find alpha plus 2 beta plus 5 gamma. That is, in short, you need to find alpha, beta and gamma to obtain the final answer. Okay, so how are you going to do this one? See, in 2D geometry as well as in vector also, there is a relation between, so what is an orthocenter? Before that, what is an orthocenter, circumcenter? Orthocenter is the point of concurrence of altitudes of a triangle, and what is a circumcenter? The point of concurrence of perpendicular bisectors of a triangle. There is one more thing thing like this, that is a point of concurrence of medians of a triangle, that is centroid. Okay, see the relation between these three, that is orthocenter, circumcenter and centroid, is like 3 of them are collinear, that is they lie on a same straight line. Okay, and what is the see, if they lie on a same straight line, there will be a division formula which can be applicable there, which will be like orthocenter, okay, orthocenter divides centroid and circumcenter. Okay, centroid divides orthocenter and circumcenter internally in the ratio 2:1. Okay, so let's do this. It will be orthocenter, that is vector p plus vector q plus vector r divided by 4. Circumcenter is given like alpha vector p plus beta vector q plus gamma vector r. And what is the centroid? If you add all the position vectors and divide it with 3, you'll get the centroid. That is, add all of it. That is 4 vector p, 6 vector p minus 5 vector p is vector p, vector q, 2 vector q and minus vector q, that is vector q. Okay. Next one is 2 vector r, 4 vector r minus 3 vector r plus vector r divided by 3. Okay, then use the internal division formula for vectors. You will easily get the answer. Therefore, it can be written like 2 alpha. This is how you multiply. Okay, you know that. That is 2 alpha vector p plus 2 beta vector q plus 2 gamma vector r. Okay. Plus vector p plus vector q plus vector r divided by 4 whole divided by 2 plus 1, which is equal to 3, and that will be equal to vector p plus vector q plus vector r divided by 3. Okay, so this 3 and this 3 got cancelled and only the numerators will be there. Then I am multiplying both sides with 4, so okay, 4, it will be 8 alpha vector p plus 8 beta vector q plus 8 gamma vector r plus this will be vector p plus vector q plus vector r. Okay, I am skipping a step here. Okay, please be careful. After multiplying LHS and RHS with 4, this will be transformed like this. This will be vector p plus vector q plus vector r, and this will be 4 vector p plus 4 vector q plus 4 vector r. Okay, therefore vector p minus 4 vector p is 3 vector p, q minus 4 vector p is q is 3 vector q, like that. Therefore it will be 3 vector p plus 3 vector q plus 3 vector r. Okay, that's done. Okay, if you compare it with the LHS, it will be 8 alpha is equal to 3. That is 8 alpha is equal to 3. Therefore alpha will be 3 by 8. Okay, I think same will be for beta and gamma. 8 beta is equal to 3. Therefore beta is also equal to 3 by 8, which will be equal to gamma. Therefore alpha is equal to beta is equal to gamma is equal to what? 3 by 8. Okay, so moving towards the final cut. Therefore we need to find alpha plus 2 beta plus 5 gamma, right? That is, as all of them are alpha, we can assign alpha here and here as well. Therefore, that is nothing but alpha plus 2 alpha plus 5 alpha. That is what? 8 alpha. That is 8 alpha. And what is the value of alpha? 3 by 8. That is 8 into 3 by 8. Cancel it. That is first option. It is the correct one. Okay. That's all. Done. And the next question. Okay. 2024, vector A is equal to I plus j plus k, vector B is equal to 2i plus 4j minus 5k, and vector C is equal to xi plus 2j plus 3k. Okay, x is the element of R. If vector D is the unit vector in the direction of vector B plus vector C such that vector A dot vector D is equal to 1. Okay, and then you need to find vector A cross vector B dot vector C. That is basically the triple product. Okay, scalar triple product. Okay, the vector D is the unit vector in the direction of vector B plus vector C, right? That is, vector D is equal to vector B plus vector C divided by magnitude of vector B plus vector C. Okay, there is one more data given like vector A dot vector D is equal to 1. I am going to dot it. That is, vector A dot vector D is equal to vector A dot vector B plus vector C. Okay. Divided by magnitude of vector B plus vector C. Okay, sorry. Magnitude of vector B plus vector C. What is the value here? 1. We can write that here. Okay. So, first thing first, we can find vector B plus vector C. What is vector B plus vector C? So, vector B, I am writing the numbers only 2, 4, minus 5. Vector C, that is x, 2, 3. And vector A for later, that is 1, 1, 1. Okay. Okay, that is 2 plus x. Okay, that is 2 plus x dot C, vector B plus C dot vector A, right? That is 2 plus x dot 1. That is 2 plus x itself. Okay. 4 plus 2, 6 plus 1 into 1. That is plus 6. Minus 5 plus 3, minus 2 into 1, that is minus 2. Okay. And what is magnitude of vector b plus vector c? That is square of, that is x plus 2 the whole square plus 4 plus 2. That is 6 square plus minus 2 the whole square, which is equal to 1. Okay, that is this 2 and 2 got cancelled. This becomes x plus 6. We need to find x, right? Therefore, we can square both sides. You will get this becomes x plus 6 the whole square, which is equal to cross multiply and eliminate the root. This will be x plus 2 the whole square plus, see what is the value of 6 square plus minus 2 square, 36 plus 4, which is 40. Okay, so this will be x square plus 12x plus 36 is equal to x square plus 4x plus 4 plus 30. Okay, x square got cancelled, and 36, this is 40. Okay, 40 plus 44, that is 36. 44 minus 36 is 8. Okay, 12x minus 4x is 8x. 8x is equal to 8. Therefore, the value of x is what? Nothing but 1. Okay, then we can substitute 1 for x. We will get c is as I plus 2j plus 3k. And you need to find the box product ABC. How are you going to find box product ABC? Okay, in the next slide, that is vector A cross vector B dot vector C is equal to box product vector A, vector B, vector C. Okay, so if vector A is equal to A1I plus A2J plus A3K, and like that vector B is equal to B1I plus B2J plus B3K, and vector C is equal to C1I plus C2J plus C3K, then box product ABC will be A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, like that. A1, A2, A3, B1, B2, B3, C1, C2, C3. So in here we need to find box product ABC. Therefore, we can formulate a determinant here. That is, what is A? A is written here 1, 1, 1, right? 1, 1, 1. And what about B? B is 2, 4, minus 5. 2, 4, minus 5. And C is 1, 2, 3. Okay, therefore it will be 12 plus 10. That is 22 minus 6 plus 5. That is 11 plus 0. Okay, therefore the result is what? 11. But I think, yeah, here the option is 11. Okay. Okay, that is, it is actually 11. Okay, 11 is the final cut answer for this one. Okay, I hope you got the idea here. Was a very easy question and can be easily formulated also. Okay, so about that, next question. Okay, same one. Vector A is equal to I plus 2j plus 3k. Vector B is equal to 2i plus 3j minus 5k. And vector C is equal to 3i minus j plus lambda k. Okay, B three vectors. Let vector R be a unit vector along vector B plus vector C. Same. And vector R dot vector A is equal to 3. Then you need to find 3 lambda. Okay. In the previous question, you need to find x and the cross product. Here we need to formulate alpha only. Okay. We can try to solve this. Vector R is a unit vector along vector B plus vector C. That is, vector R is equal to vector B plus vector C divided by magnitude of vector B plus vector C and dotted with A. That is, vector R dot vector A is equal to vector A dot vector B plus vector C. See, vector addition is commutative. Therefore, in the left hand side or right hand side, it is not having much concern. Okay, that's fine. And magnitude of vector B plus vector C, which we can formulate exactly like the previous question. Vector B, I am formulating the numbers only 2, 3, minus 5, and vector C. Vector C is equal to 3 minus 1 lambda. Okay. Okay, and A is 1, 2, 3. Okay, so what is vector B plus vector C? That is 2 plus 3 is 5. 5 into 1 is 5 itself. That is, this is equal to 3. Okay, vector R dot vector A is equal to 3. Okay, that is, this will be 3 plus minus 1, that is 2, and 2 into 2 is what? 4. And this is minus 5 plus lambda or lambda minus 5. Lambda minus 5, okay, into 3. That is, I think there will be 3 lambda minus 15 will be there, divided by the magnitude of this square. What is 2? That is, B is 5, B plus C is 5i plus 2j plus lambda minus 5 into k. Okay, and what is the magnitude of that? It will be root of 5 square plus 2 square plus lambda minus 5 the whole square, which is equal to 3. I hope you got the idea here. So this will be 5 plus 4, that is 9. That is 9 plus 3 lambda minus 15. Okay, that will be 3 lambda minus 6, and that will be 3 into lambda minus 2. Okay, therefore this will be, I am writing it here, 3 into lambda minus 2 divided by root of 5 square plus 2 square, that is 29. 29 plus lambda minus 5 the whole square, which is equal to 3. Got cancelled. Cross multiply and square both sides. It will be lambda minus 2 whole square is equal to 29 plus lambda minus 5 the whole square. Therefore, it will be lambda minus 2 the whole square is equal to 29 plus lambda minus 5 the whole square. Therefore, lambda square minus 4 lambda plus 4 is equal to 29 plus lambda square minus 10 lambda plus 25. Lambda square got cancelled. This becomes 6 lambda. Okay, and 29 plus 25 is 54. Minus 4 is what? 50. That is 6 lambda is equal to 50. Therefore, 3 lambda is equal to 25. Option C. Correct one. Was a very easy question. Okay. Hope you are getting the idea here. Okay, pardon me if I am getting speeding up for the basic calculations. Okay, see, the thing is, only here I can put up some speed. Okay, while concept breaking we cannot push further. Okay, we cannot reduce the speed. Okay, but for basic calculation you will be able to sort out this one by yourself. Okay, either by this method or any method. There are numerous methods for obtaining lambda here. Okay, either by cross multiplication like that. Okay, so that you can do it by yourself, and if you want to add more steps then you can add that also. Okay, but eventually just keep one thing in mind, in examination the time is very crucial. As much steps you can skip the basic calculation, you can skip without sacrificing your final answer. Okay, that will be better, especially for maths. Okay, the next question. Okay, a unit vector u, that is xi plus yj plus zk, makes angles pi by 2, pi by 3 and 2 pi by 3 with the vectors, 3 vectors are given, right? I by root 2, k by plus k by root 2, j by root 2 plus k by root 2, I by root 2 plus j by root 2. All 3 are unit vectors. Observe, it's not given in the question, but it is like that. And another vector v is given like, it is given, that is 1 by root 2 I plus 1 by root 2 j plus 1 by root 2 k. Then you need to find vector u minus vector v the whole square, the value of that. Okay, so how are you going to formulate that? Okay, let's start first things first. It is a unit vector, therefore its magnitude will be 1 and the square of the magnitude will also be equal to 1. That is, the square of magnitude will be x square plus y square plus z square is equal to 1. Okay, let's name these vectors. This is vector A and this should be vector B and this is vector C. Okay. The angle made by this vector with respect to vector A is pi by 2. Therefore, their dot product will be 0. And it will be like x by root 2 plus z by root 2. Okay, is equal to 0. That is x plus z is equal to 0. Number 1. Next one. With this is what? Vector B is pi by 3. That is cos pi by 3 is equal to dot product of this and this. I is not the, we don't have to bother. That is y by root 2 plus z by root 2. That is vector C. It will be vector u dot vector B divided by magnitude of vector u into magnitude of vector B. That will be cos pi by 3. But we don't have to bother about the denominator for the other case also, because the unit vectors are, so the new denominators are unit vectors. Okay, magnitude of u, that is a unit vector which is given in the question, and vector b, if you square and add it up, it is a unit vector. Okay, therefore we don't have to bother about the denominators for the next case also. Okay, so what is cos pi by 3? Cos 60 is 1 by 2. That is y plus z by root 2 is equal to 1 by 2. That is y plus z is equal to 1 by root 2. Okay, and the next one, cos 2 pi by 3. Cos 2 pi by 3, I think that is minus 1 by 2, right? This will be x by root 2 plus y by root 2. If you dot this and this by unit vectors, you don't have to consider about that. Therefore, it will be x plus y by root 2 is equal to minus 1 by 2. So, x plus y is equal to minus 1 by root 2. Okay. So, let's take these two equations. Okay, let's take it as equation number 1 and this as equation number 2. If you add those two, the right hand side becomes 0, right? That is, if you add the left hand side becomes x plus 2y plus z is equal to minus 1 by root 2 plus 1 by root 2, that is 0. Okay, and we have another equation like x plus z is equal to 0. Okay, therefore x plus z becomes 0. That is 2y is equal to 0. That is what is y? Y is equal to 0. Okay, if y is equal to 0, then what is z 1 by root 2 and what is x minus 1 by root 2? Okay, so now you got x, y and z. That is x is equal to y is equal to 0, right? X is equal to minus 1 by root 2 and z is equal to 1 by root 2. Minus 1 by root 2, z is equal to 1 by root 2. Okay, you need to find vector u minus vector v, the magnitude of that square, right? And what is vector u? Minus 1 by root 2, 0, 1 by root 2. And what is vector v? 1 by root 2, 1 by root 2, 1 by root 2. 1 by root 2. Okay, so this will be 2 by root 2. This is 1 by root 2 and this is 0. If you square it up, it will be 4 by 2 plus 1 by 2 plus 0. That is 4 by 2 plus 1 by 2 is 5 by 2. That is, the result is 5 by 2. Okay, let's check. Okay, option D. Okay, a very easy question, but the calculation is a bit more. Okay, doable one. So, the next one. Okay, very easy question. 3 vectors are given. Vector A, vector B, vector C are given. And a vector P, another vector is given which satisfies the relation like vector P cross vector B is equal to vector C cross vector B. Do you recall this relation? In the first question we have discussed this. Okay, aligning the vectors like that. And another relation is given like vector P dot vector A is equal to 0. Then you need to formulate vector P dot I minus J minus K is equal to 0. Okay. How are you going to formulate that? Easy one actually. So let's take this to the left hand side. This becomes vector P cross vector B minus vector C cross vector B is equal to 0 vector. That is vector P minus vector C cross vector B is equal to 0 vector. Okay. Therefore, vector P minus vector C is equal to lambda vector and vector P is equal to the formula, that is cross product of two vectors are 0 vector is a 0 vector, then one vector can be represented as a scalar multiple of another vector. Okay, therefore vector P is equal to vector C plus lambda vector P. Okay, and they have given additional information like vector P dot vector A is equal to 0. So dotting with A on both sides. That is vector P dot vector A is equal to vector C dot vector A plus lambda into vector B dot vector A. Okay, this is 0. Okay, this is 0. That is lambda is equal to minus vector C dot vector A divided by vector B dot vector A. Hope you are getting the idea here. Okay, let's mark the vectors first. That is 3, 1, minus 2. Okay, that is A. B is 4, 1, 7 and B is 4, 1, 7. And what about C? C is 1, minus 3, 4. Okay, what is vector C dot vector A? Vector C dot vector A is, this is 3, minus 3, that is 3 plus minus 3 minus 8, that is lambda is equal to minus of minus 8 divided by what is vector b dot vector a, that is 12, 1 and minus 14, that is 13 minus 14, that is minus 1. Therefore, lambda is equal to minus 8. So, you got the value of lambda, then we can easily formulate p from that. That is, p is equal to vector c minus 8 vector b. Okay. So, what was vector c? 1 minus 3, 4. And what is 8 vector b? 32, 8, 56. Okay. 32, 8, 56. If you subtract it, you will get vector p is equal to minus 31i minus 11j minus 52k. Okay, here we need to dot with I minus j minus k. That is I minus j minus k. So it will be, I can write that here, that is minus 31. This will be plus 1. This will be 11. Plus 11. This will be plus 52. That is 52 plus 11 is 63. 63 minus 31 is 32. Okay. So 32 is the answer. Okay. That was a very easy question. Okay. And doable also. The next one. Okay. Two vectors are given. Vector A and vector B is given. And vector C be three vectors such that vector C plus I cross vector A plus vector B plus I is equal to vector A cross vector C plus vector I. Okay. Dot product relation is given like vector A dot vector C is equal to minus 29. And then we need to formulate vector C dot minus 2y plus j plus k. Okay. If you want, you can pause the video and do it by yourself. Okay. Just to try and figure it out. See, first thing is the vectors are the vector which is common is not aligned. Here it is the first vector and here it is second vector. It should be aligned. So I'm making it as the first vector using cross product. I'm writing it here itself minus vector c plus I cross vector A. And if you take it towards the left hand side, it becomes plus. That is vector c plus I cross vector A plus vector B plus vector I plus vector C plus I cross vector A is equal to 0 vector. Okay. So we can take vector C plus vector I as common. That is vector C plus vector I cross C. Cross becomes vector A plus vector B plus vector I plus vector A. That is 2 vector A plus vector B plus vector I, which is equal to 0 vector. Okay, I hope you are getting the idea here. Therefore, vector C plus I is equal to lambda into 2 vector A plus vector B plus vector I. And vector C is equal to lambda into this minus I, that we can perform later. And there is another thing which is like vector A dot vector C is equal to minus 29. We can multiply both sides with A. Therefore, we will get vector A dot vector C plus vector A dot I, which is equal to lambda into, this becomes 2 into magnitude of A square plus vector A dot vector A plus vector A dot vector B plus vector A dot vector I. Okay. Okay. And what is vector A dot vector C? That is minus 29. Minus 29 plus what is vector A dot I? A is 2i plus 5j minus k. Dot I is 2. Okay, that is 2 is equal to lambda into 2 into what is magnitude of A square? 2 square 5 4 plus 5 25 30. Okay, into 30 plus what is vector A dot vector B? That is 2 5 minus 1 2 5 minus 1 2 minus 2 2, that is 4 minus 10 minus 2, that is minus 8, right? That is minus 8 plus this we have already formulated, that is 2. Okay, that is 60 62 54, that is 54 lambda 54 lambda is equal to minus 27, that is lambda is equal to minus 1 by 2. Okay, that's fine. Okay, lambda is equal to minus 1 by 2. Okay, so what is vector C plus vector I? That is lambda into 2 vector A plus vector B plus vector I. Okay, we can formulate it. What is 2 times vector A? let's substitute the value of lambda here first. That is vector c plus I is equal to minus 1 by 2 into, in here I am going to substitute. I think it will be better if you operate this all. Okay, what is 2 times vector A? That is 4, 10 and minus 2, right? And vector B, 2 minus 2, 2 and I only. Therefore here it will be 1, 0, 0. That is, it will be 4, 6, 7. That is 7I plus 8J. Okay. It's 2 got cancelled, right? Okay, fine. That is vector C is equal to minus 7 by 2I minus 4J minus I. Okay. So this will be vector C is equal to minus 9 by 2I minus 4J. Okay, that's all. Into 2I minus 2I plus J plus K. That's also the I think it will be better if you move to the next slide. That is next one. Minus 9 by 2I minus 4J. That is vector C is equal to minus 9 by 2I minus 4J. And this is minus 2, 1, 1. That is minus 2, 1, 1. Okay, this is 0 here. That is 9 minus 4. That is the value is 5. Okay, is 5 in the option? Yeah, this one is the correct one. Okay. That's all. Okay, see, if you look at the questions here, almost all questions are same. Okay, that is the trend recently. After 2023, it is like this. So many questions from 2024 is repeatedly asking based on the concept, not the numerical figures, but concept-wise it is asking, and they are making minute changes in the question. Okay, that you already knew. Okay, and that's all. Next one for this question. Next one. Okay. Again 2 vector is given and another vector C, and this is also given. Okay, vector A is equal to I minus 3J plus 7K, vector B is equal to 2I minus J plus K, vector C be another vector such that vector A plus 2 vector B cross vector C is equal to 3 into vector C cross vector A, and vector A dot vector C is equal to 130, and you need to find vector B dot vector C. So how are you going to formulate vector B dot vector C? We need to find vector C first, right? Okay, let's open the bracket here. Let's see what happens. There is nothing common. Let's open the bracket first. That is, no other data is given. Okay, that is vector A cross vector C plus 2 into vector B cross vector C is equal to 3 into vector C cross vector A. Okay. If you transform this only, it becomes minus of 3 into vector A cross vector C. Okay. And if you take this left hand side, it becomes plus 3 into vector A cross vector C, right? Vector A cross vector C plus 2 into vector B cross vector C. If you take this to the right hand side, it becomes 3 plus 1 is 4. That is, these are like terms, like vectors. Okay. That is 4 into vector A cross vector C plus 2 into vector B cross vector C is equal to 0 vector. Okay, we can cancel this, and this becomes 2. Okay, vector C is common and it is aligned. Okay, that is 2 vector A plus vector B cross vector C is equal to 0 vectors. That is 2 vector A plus vector B is equal to lambda vector C. And the data is given, dotted with A. That is 2 times magnitude of A square plus vector A dot vector B is equal to lambda into vector A dot vector C. So what is magnitude of A square? That is 49 plus 50. 50 plus 9, 59 into 2 is 118 plus vector A dot vector B. We can place B here, 2 minus 1 and 1, right? That is, it will be 2 plus 3 plus 7, that is 12. Plus 12 is equal to lambda into 130. So what is the value of lambda? See, this is 130 and 130, that is 1. Lambda is equal to 1. That's done then. So what is vector C? That is 2 vector A plus vector B. Okay. You need to find vector B dot vector C, right? We can directly apply dot product here. That is vector b dot vector c is equal to 2 into vector a dot vector b plus magnitude of vector b the whole square. That is 2 into, I think, what's, okay, vector a dot vector b, we already formulated that the value is 12. 12 plus magnitude of b square, right? That is 1 square plus 2 square plus minus 1 square plus 1 square, 4 plus 1 plus 1, that is 6. That is 6. Okay, that is 24 plus 6, that is 30. 30 is the final cut answer. Okay, that's all. It was a very easy question. Okay, next one. Okay, a new type, not a new type, already existing one. The position vectors of the vertices ABC of a triangle are 2i minus 3j plus 3k, 2i plus 2j plus 3k, and minus I plus j plus 3k respectively. Let L denotes the length of the angle bisector AD of angle BAC, where D is on the line segment BC, then 2L square is equal to. Let's start with the figure first. Okay. Position vectors means I am taking this only, that is the points only, that is 2 minus 3 and 3. This is 2, 2, 3, right? That is 2, 2, 3, and this is minus 1, 1, 3. Okay, if the question based on angular bisector is given, just go for finding the sides first, length of sides first. Okay. What is magnitude of vector AB? Or what? That is AB. Side AB, which is equal to magnitude of vector AB. Okay, it's fine. Which is equal to 2 minus 2 got cancelled. This is 5 square got cancelled. That is 5. Okay. And what is this one? AZ. That is 3 square plus 4 square. That is also equal to 5. That is where AC is equal to magnitude of vector AC is equal to 5. Okay. Angular bisector of BAC, right? Therefore, it is like this. Since it is the bisector, these two angles will be same. Okay, we already cracked the problem because it is 5 and it is also 5. See, using SAS postulate, these two angles are congruent. Therefore, this side and this, see, this side and the included angle are same for two triangles. Therefore, they are congruent triangles. Therefore, this is the midpoint of, see, this length and this length will be same. Therefore, this is the midpoint of the two triangles. The midpoint will be like 2 plus minus 1, that is 1. 1 by 2. 2 plus 1, that is 3. That is 3 by 2 and 3. Okay. This is D, right? Okay. Angle AD of BAC. Okay. L denotes the length of the angular bisector AD. That is, this is L, right? So it's done. Just use the shortest distance formula. It's done. You got the answer already. That is AD is equal to square root of 2 minus 1 by 2. 2 minus 1 by 2 the whole square plus minus 3 by 2 the whole square plus 3 minus 3 the whole square. It's got cancelled. This will be 2 minus 0.5, that is 1.5, that is 3 by 2, that is 9 by 4. 9 by 4 plus this is minus 6 minus 81 by 4, that is 81 by 4. Okay, so AD is equal to, that is AD, okay, this is AD square, okay, sorry, this is AD square, and AD square is L square. L square is equal to 90 by 4. That is L square is equal to 45 by 2. But you need to find the value of 2L square. And what is 2L square? 45. Okay. A very easy question. But most students will skip this question by thinking that they do not know the formula of angular bisectors and such that. Okay. There is a formula indeed. But here it is not. There is no need of applying that here. Okay. The next one. Okay. Again a question, but okay, I will tell you. Vector A, vector B is given and vector C is also given. Okay. Vector R is a vector such that vector R cross vector A is equal to vector B plus vector C cross vector A. Okay. And they have given like vector R dot vector B minus C is equal to 0. See, exactly same to the question which we done just before. then you need to find the value of 593 vector r plus 67 vector a divided by 593 the whole square. Okay, let's try and solve this one. Okay, it's a very easy question actually. Okay, let's formulate by starting here first. I'm taking this to the left hand side. This becomes vector r cross vector a minus vector b plus vector c cross vector a is equal to 0 vector. Okay, and it will be like vector r minus vector b plus vector c cross vector a is equal to 0 vector. Okay, next one, that is vector r minus vector b plus vector c is equal to lambda vector a, the property which we discussed in the previous questions, and vector r is equal to lambda vector a plus vector b plus vector c. Vector r is equal to lambda vector a plus vector b plus vector c. Okay, that's done. And okay, the relation is like vector r dot vector b minus c is equal to 0. Therefore, you know what to do next. Multiply both sides with vector b minus c. Apply dot product on both sides. That is vector r dot vector b minus vector c is equal to lambda into vector a into vector b minus vector c dot plus vector b plus vector c dot vector b minus vector c. Okay. Therefore, 0 is equal to lambda into what is vector a? That is 9 minus 13 and 25. Okay. And what is vector b? Okay, b 3 7 minus 13. This is a, and b is 3 7 minus 13. And what about c? 17 minus 2 and 1. Okay. That is we can formulate b minus c first. What will be b minus c? Minus 14 minus 9 and minus plus 9, minus 14 plus 9 and minus 14. Okay, then multiply this with a. So what is 9 into minus 14? That is, I am formulating this one. Okay, I have formulated b minus c. I am dotting it with a. That is minus 14 to 9 is minus 126 and minus 117 and 25 into 14. 350 minus 350. Okay, plus this will be magnitude of b square minus magnitude of c square. Okay, this vector b plus vector c dot vector b minus vector c. I am going to write it here. Vector b plus vector c dot vector b minus vector c is equal to magnitude of b square minus magnitude of c square. Okay. So, what is magnitude of b square? That is 3 square. 7 square is 49. 49 plus 9, 58. 58 plus 169. That is 58, 169. That is 210, 227. That is 227 minus. What is magnitude of c square? This is what c square is. 289, 90, 294. Minus 294. Okay, so this is our parent equation. That is 0 is equal to, this is minus 243 and minus 593. That is minus 593 lambda. This is minus 67. Minus 67. Okay, so we will obtain lambda from here. Lambda is equal to, in the next slide. Okay, lambda is equal to 67 by 593. Minus 67 by 593. Lambda is equal to minus 67 divided by 593. Okay. We can substitute the value of lambda here. What is vector r? Vector r is equal to lambda vector a plus vector b plus vector c. Okay. Plus vector b plus vector c. So what is lambda? That is vector a is equal to minus 67 divided by 593 into vector a plus vector b plus vector c. That we can directly write here, vector b plus vector c. Okay. Okay, the final answer is in terms of vector r and vector a. Therefore, we don't have to substitute vector a here. But vector b plus vector c, that we can directly write there. What is vector b plus vector c? Okay, it will be 320i. That is 20i and plus 5j. Plus 5j and minus 12k. Minus 12k. That is 25 minus 12. That is 25 minus 12k. Okay, this is what our final equation looks like. Okay, towards the answer. Okay. Do one thing, multiply every side with 593. That is 593 vector r is equal to minus 67 vector a plus 593 into 20i plus 5j minus 12k. And this you get here, it will be 593 vector r plus 67 vector a divided by 593 is equal to 20i plus 5j minus 12k. Okay. Take magnitude on both sides and square it. That is, the square of this will be the magnitude of square of this. What is the magnitude of this one? That is root of 20 square plus 5 square plus minus 12 square. If you square it, the root will get cancelled. Therefore, the final result will be 20 square plus 5 square plus minus 12 the whole square. That is 400 plus 5 is 425. And 425, 144, that is 569. That is 569 is our final cut answer. Okay. It's integer type. Yeah, it's an integer type question. Therefore, 569 is the final cut answer. Okay. I hope you got the idea here. Next one. Next question. Okay, another doable question. Consider a triangle ABC where A 132, B minus 280 and C 367. Okay. If the angle bisector of angle BAC same meets the line BC at D, the length of projection of vector AD on the vector AC. It's done. You know how the formula of this one, right? I think it will be similar to the previous one. Okay, let's work it out. That is A, B and what? C. A is 1, 3, 2 and B is minus 2, 8, 0 and what about C? 3, 6 and 7. The angular bisector of angle BAC, that is this one, line meets the line BC at D. Similar to the previous one, right? Even the alphabets are same. Okay, let's this will be same since it's internal angular bisector. Let's try and find out the distances first, and if we can apply SOS postulate, the question becomes easier. Okay, so what is AB? 1 minus, that is 3 square, 3 square plus 5 square plus 2 square, that is 3 square plus 5 square plus 2 square, 9, 25, 34, root 38, that is root 38. And what about AC? That is 2 square, 1 minus 3 is minus 2 whole square, 2 square plus 3 square plus 5 square. It's same, right? That is root 38. So this and this are same. So this is applying SAS postulate. This side and this side, the length will be same. So basically D is the midpoint. So what is B? 3 plus minus 2 is 1. 1 by 2. 8 plus 6, 14. 7. 14 by 2, 7. 0 plus 7, that is 7 by 2. Okay, that is what D is. You need to find the projection of vector AD on vector AC, right? Vector AD on vector AC. Okay. Before that, we need to formulate vector AD and vector AC. What is vector AD? Position vector of D minus position vector of A. That is minus 1 by 2i plus 4j plus this is 3.5. 3.5 minus 2 is 1.5. That is 3 by 2j. Okay. Next one, vector AC. Again, position vector of C minus position vector of A. That is 2i plus 3j plus 5k. Okay. And we know, we very well know the projection formula here. Vector AD on vector AC, right? That is vector AD dot vector AC divided by magnitude of vector AC. Okay. If you dot it up, you will get minus 1 and plus 12 plus 15 by 2. Okay. This will be 11. 11 plus 15 by 2, right? And 12 22, 37 by 2. The top part becomes 37 by 2 divided by what is magnitude of AC? That is, it will be root of 2 square vector AC. This is already given. Okay, root 38. We already obtained that. That is root 38. Okay, so the final cut result will be 37 by 2 root 38. This one. Okay. Okay. So that's it. We have discussed so many questions from this topic. Okay, there will be one more session for vectors. Okay. And by that we will be concluding vectors. Okay, so hopefully you got some idea regarding this topic. Okay, try and do and go through these questions one more time without looking at the solutions and just rely completely on the keys. Okay, so once again, thank you for listening and have a nice day.